Alright, so in this video, it's going to be a fairly short video, we're just going to look at linear functions, two special types of linear functions. Alright, the horizontal line and the vertical line. They have a very special type of slope and they're a very special type of line. Alright, so the first one, vertical lines. Alright, vertical lines are always of the form x equals a number, right? D just represents a real number value. So if you have a line that's represented by x equals a number, and again, it can be any real number value, that is a vertical line that's moving straight up and straight down. All vertical lines are parallel to the y-axis, and if you look at my example here, you'll see that this blue line is parallel to my y-axis. Always. So every single vertical line is parallel. Actually, the y-axis is a vertical line. The y-axis is the vertical line. X equals 0. Just that kind of FYI there. All vertical lines have a slope that is undefined. And the reason why the slope is undefined is because on vertical lines, all of your x values are the same. They're equal to whatever that number d is. Every x value on my line is equal to d. Alright, so every single point on this line, if I pick any point, any 2 points on this line, x value would be d, y value is 3 in that case, x value is d, y value would be 1 in that case. So again, any point on this line, x value is d, y can be anything, right? Anything, because I'm moving up and down, it can be anything between infinity and negative infinity. Alright, but x is d. All of my x values are exactly the same, and because of that, when I go to find my slope, my change in y over my change in x, well, there is no change in x. That's 0, right? Because that would be d minus d. Right, the y values would come out to some number. But I would get division by 0, which is an error. Again, that means the slope is undefined. Doesn't exist. It doesn't. Again, slope gives you increase or decrease. Well, this function, when it's a vertical, is moving perfectly straight up to infinity. So it's perfectly increasing. But at the same time, it's moving perfectly straight down to negative infinity. And so there's no way to talk about that in terms of increase or decrease. It's perfectly up and perfectly down. So it's increasing and decreasing all at the same time. Perfectly, right? Perfect increase, perfect decrease. And so it's undefinable. You can't define it. Right? Again, the reason why is you get division by 0. There is no change in x in this case. And because of that, if you look at it, vertical line, remember when we test for functions, we have the vertical line test. Alright? It fails the vertical line test because it is a vertical line, right? There are infinitely many y values for one x value. Right, remember, if I've got more than one y value per x value, it's not a function. Right, so vertical lines are not functions. Right, they're special lines, they're important lines, but they're not function lines. Right, the second special one is the horizontal line. Right, this is also a very special line. It actually is a very special type of function, so this one is a function. Right, vertical lines are always of the form y equals some real number value. Right, so if you ever have a line and all it is equal to is a number, it's a horizontal line. Horizontal lines are parallel to the x-axis. Actually, the x-axis is a very special line, y equals 0. Right, it's a very special horizontal line, y equals 0. Slope of all vertical lines are 0. They're flat, right? They're flat lines. The slope is 0 because all of the y values on my function are the same, right? If I pick any y value, any 2 points, I pick a point here, I'll pick a point here, alright, and I have that point. Well, that point is the x value is negative 3, but the y value is c. Alright, same thing with this point. X value is 1, y value is c. All of my y values are c. X can be anything from infinity to negative infinity. X changes. But y doesn't. Y has to be whatever the c value is. Right? It's flat. So there's no change in y in this case. So if I wanted to find my slope, remember change in y over change in x, Well, I have a change in x, right? X values change. And so if I use the two that I have, so negative 3 to 1, that x value would be negative 3 minus 1 would be negative 4. But up top, it would be c minus c, which would 0 away. Well, I can, unlike dividing by 0, you can get your calculator out. You could take 0 divided by negative 4, and that's fine. 0 divided by any number is 0. And so my slope is 0 in this case. And another way to think about it, it's a flat line. Right? Remember, slope tells me increase and decrease. Well, a flat line is neither increasing nor decreasing. There's no change, right, in my function when I change x, right? The x values are changing, but the y values are staying the same. And so my function never changes. It's always whatever that c value is. And so it is a non-increasing, non-decreasing. Slope means there's no change. Right? The horizontal lines are functions. It passes the vertical. If I do a vertical line test, it does pass the vertical line. They're very special functions called a constant function. Alright? The definition of a constant function then is a function represented by a number that's constant. It's a fixed real number. And so a constant function is whenever I have f of x equal to, say, 2. That's a constant function. Or f of x equal to negative 10. That's a constant function. And those are my very special horizontal lines. Right? They're horizontal lines in those cases. They're constants. They're constant because the function is constantly the same thing. No matter what x value I plug in, no matter what input I plug in, I'm going to get the same y value, the constant, out. Alright, so again, there's no change in my function. Slope is 0. Alright, so we'll stop there. That was a quick review of special lines and the constant function.